This is Isaac Ferry with Crop Tech Consulting, bringing you this week's edition of Technology Tuesday. The first step to implementing variable rate technology on your farm is to identify sound management zones. This week's session walks us through some of the steps and thought processes that we use with our farmers to identify management zones within their fields. As yield monitors become more and more prevalent, and a lot of guys are starting to get their own software to analyze, print, and use these yield maps to make management decisions, a lot of guys are moving into variable rate. And one of the biggest questions we get is, as they move into variable rate, they're wondering, how do I set my rates for the next year? Do I take them up? Do I take them down? What do I do with fertility? What do I do with population? What do I do with nitrogen? There's definitely no easy answer, but one of the things that we stress is that before we do any type of variable rate across the whole field, we definitely need to identify management zones. And realize that I'm saying identify management zones, not create management zones. So we're not going out there on a grid-based system, creating grids across the field and creating these square management zones that we're somehow going to variable rate fertilizer, variable rate lime, variable rate population, based upon this arbitrary grid that we created. What we need to do is identify management zones. So here's a perfect map. As we look at it, all of a sudden we see these different zones within the field that are yielding drastically different than the areas around them. We're identifying naturally varying parts of the field, and we're going to cut those out and manage those naturally varying parts different than the rest of the field as per their needs. So identifying the natural variability within your field is key, which means you do have to have a well-calibrated yield monitor. Or you do have to have some aerial imagery, some NDVI or thermal imagery, something to start to show you where these management zones are. Because we want to be able to map the natural variability and then respond to whatever the limiting factors are in each one of those zones, which could be different inputs altogether, or it could be the same input at different rates. And we try to tell guys that moving into a full variable rate system takes about 3 years of good yield maps, of imagery, of intense scouting to really identify where these management zones are and what their limiting factors, could be or are. So we definitely start, guys, creating good yield maps, cutting these management zones in, and really trying to get them identified. Here, when we lay over this map right here, a couple things we notice. So we have soil types in here. This whole run right through here is a 152 soil type. And we notice this map responds very, very drastically to that soil type. So we use that as our main layer when we start to cut stuff up. But we do notice even in this 152 soil type, there's an area in here that yields better. Granted, not as good as over here, but better than the area around it. So we even cut within that soil type, we cut our own sample out. And we're going to test that differently. It's going to get spread differently. It's going to get treated differently. And then here we still have a 152 soil type, but it's definitely yielding like this 154. As this soil type narrows up, the characteristics of this are quite a bit different than down here. And we're going to cut that out, and we're going to sample that differently. Same thing with this 154 pocket up here. There's obviously a run of soil or topography change that in this area here that makes this spot in here, even though it's classified as a 154, yield very similar to this 152. So we're going to cut that out in its own sample. We're going to sample that. Same thing here with this 154 down here, this 154. We have water runs that come through here, topography changes that make us separate those out by themselves and sample them differently. The nitrogen requirements here could be quite a bit different than they are here, just because of the loss factor, the risk of loss of nitrogen in these areas here where the water is running through than where they are right here. So that's the first part, identifying the management zones, and that is a very, very big portion of it. The second thing is, how do we set the rates? What do we do with the population? What do we do with the nitrogen? And unfortunately, there's no easy question to that, especially when you're dealing with different soil types within fields, when you're dealing with the differences, say, between Illinois and Indiana and Wisconsin. And what we have all of our clients do is put in check strips. If we're going to move into variable rate population, while those 3 years that we're creating these management zone maps, we're also making sure that if they're planting that whole field at 34,000, that in each of these fields they do 2 or 3 strips at 28,000, 30,000, 36,000 to get a range. And we start to look at Now that we have this mapping software, if we have a strip through here at 38,000, then we actually look at how did that 38,000 do in this soil type? How did that 38,000 do in this soil type? How did that 38,000 do in this zone? And we start to figure out, is population our limiting factor? Is nitrogen our limiting factor? One of the biggest things that guys want to do is, that almost always gets suggested as they start to move into it, is I'm going to take my low yielding areas and I'm going to cut back my fertility to match removal. In my high yielding areas, I'm going to push my fertility recommendations to maximize my removal there, or at least equal the removal I'm taking. The problem is, it doesn't always work like that. So here we have an area, so say this area here is yielding low because of low fertility. And now we pull the fertility back. It's going to yield lower next year. And because it yielded lower, we pull the fertility back. And then it's going to yield lower the next year. And we keep on decreasing that fertility, and we take a bad spot and we make it worse. Alright. And then especially on the fertility side, and definitely nitrogen side, a lot of times these hills that may be low yielders, or a lot of times hills that may be low yielders, will respond better to increased nitrogen rates than low valleys that have high organic matter. They have high amounts of natural N being supplied. So all of a sudden our 170 bushel knolls may respond to variable rate nitrogen or higher rates of nitrogen more effectively than some of our lower ground, which is somewhat counterintuitive. So some of it is taking nitrogen away from the areas that supply a lot of their own nitrogen late in the season and adding it to areas that are lower yielding, that you'll get a bigger bump for that nitrogen itself. So it's not just about pulling stuff back on the light ground. It may be actually adding stuff to the light ground, because it will keep responding to that nitrogen. But you're not going to know that until you get out there in some of these strips and put strips of different nitrogen rates through the field. And now you have the software to be able to come back and analyze how those strips did, because you're going to weigh those passes. You know what they yielded on a whole pass by pass basis, but now we can actually come into areas in here and collect those strips as we go through it and figure out what it actually yielded. So in this case, if I had a strip through here, say at 34,000, I could look just within the soil type, select those two strips, come down here and realize that I'm averaging 182 bushel per acre. Alright, those same strips would come out here and see how it did in the same soil type, or different soil type, same pass, and we're at 222 bushel per acre. Alright, it makes it very, very easy with a software like this, any of the yield mapping softwares out there, to be able to analyze not only pass by pass, but zone by zone, to help you make those management decisions. Do we push populations? Do we pull populations? And we use the 3 years leading up to this to figure out where our high yield potentials are and what our limiting factors are. Do we need more nitrogen? Do we need less? So in a hill, we may pull the population back because we can't support enough plants, but we may push the nitrogen ahead because that hill is not creating enough nitrogen on its own, and it keeps responding to N. It may never yield like the low ground with adequate water and adequate nitrogen, but it definitely could pay to increase nitrogen rates in some of those areas. So something to think about. There's no way to be able to tell you on your own farm what you should do across all of your acres, but definitely on-farm trials are key. And before we even get into the on-farm trials, starting to identify naturally occurring management zones in the field is where every process has to start. Thank you for watching this week's edition of Technology Tuesday. Please check our website for more information and other videos.